We want to make sure we know the difference between set notation and interval notation when we're writing domain and range. Remember, set notation uses squiggly brackets and interval notation uses round brackets and square brackets. We want to make sure we're precise in stating domain and range. When we're dealing with a graph where the points are joined, we know we have to consider all the real numbers in our domain or range. We'll be looking at discrete data versus continuous data. Discrete means you have specific points involved, but continuous graphs are those that are straight lines or circles or shapes. Continuous graphs include all the real numbers, not just specific natural numbers or whole numbers or integers. We have some symbols that you need to know. The dot colored in means you include that value. The open circle means you do not include the value. Equals, straightforward. Less than is connected with an open circle because we're not including that end value. Less than or equal to is connected to the closed circle or the point. Is such that. Positive infinity means the numbers go on forever to the right or up. Negative infinity means the numbers go on forever to the left or down. Not equal to, greater than, and greater than is connected to an open circle. Greater than or equal to is connected to the dot or the closed circle. And element. We'll go through 6 examples of domain and range written in both set notation and interval notation. Notice we have the open circle here, 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 and here. That means that end value is not included. And we have the closed circle or the dot here, here, and here. Means that end value is included. Here we have some points, and we call this a discrete graph. The set notation for domain would be simply listing the x values. Now the x is the horizontal. I pretend I'm walking along the horizontal. At this point I have a -2. At this point the x value is 0. At this point the value is 3. And the last point, the value is 2, 4, 5. And now the range would be the y values. From the origin, we can walk up, we hit 1, and then 2, here's 3, and last is 6. And we don't write interval notation for a discrete set of points. Here we have a straight line where all of the x's start at -4 and end at 5. The domain then is x is such that we're going from -4 to 5, and 4 is not included, 5 is included, comma, x is an element of the reals. We say that all of the x's are greater than -4 and less than or equal to 5. The range then for set notation would be y is such that y goes from 1, 2 to 4. We go from 2 to 4, and we do not include 2, but we include 4, comma, y is an element of the reals. We say all of the y's are greater than 2, but less than or equal to 4. Interval notation, we go from -4 to 5. 5's included, -4 is not, and the range will go from 2 to 4. Include 4, but don't include 2. We start with the domain by looking at the x values. Start our walk from here and end right here. -2, -7. The x's go from -7 to -2. We write squiggly brackets. X is such that -7 to -2. All of the x's are between those values. -7 is included and -2 is not. Comma, x is an element of the reals. The range then involves the y values. We'll start walking along the y-axis and stop here. 2, 4, we go from 5 to 9, where 5 is included and 9 is not. Y is such that 5 is less than or equal to y, and also less than 9, comma, y is an element of the reals. We say all of the y's are greater than or equal to 5 and less than 9. Interval notation, domain, we go from -7 to -2, include -7 and don't include -2. And the range would be from 5 to 9, not including 9, but including 5. We can also write the domain and range for a two-dimensional shape where the line is continuous. We have domain for the x's goes from -6 to 2. So we would write domain is equal to, bracket, x is such that, we go from -6 to 2, where -6 is included and 2 is included, comma, x is an element of the reals. We say all of the x's are bigger than or equal to -6 and less than or equal to 2. For the range, we go from 0 to 2, 4, 6. We say y is such that 0 is less than or equal to y, which is less than or equal to 6, comma, y is an element of the reals. We need the equals underneath these signs because the values are included, because 6 is included and 0 is included. We say that all of the y's are greater than or equal to 0 and less than or equal to 6. The domain for interval notation would be -6, 2 with square brackets. And the range is 0, 6, where both endpoints are included. Set notation, the domain goes from here to here, -5 to 2. Domain is x is such that we're going from -5 to 2 in the x's, where we're not including both of those endpoints. We don't need the equals underneath. We have x as an element of the reals. X is bigger than -5 and less than 2. For the range, we go from here, 2, 4, 5, all the way up to here, 8. Y is such that we're going from 5 to 8, and we're including 5, but we're not including 8. Comma, y is an element of the reals. Y's are greater than or equal to 5 and less than 8. And the domain will go from -5 to 2. Both ends are not included. And the range is 5 to 8. 5's included and 8 is not. We're going from here to here in the x. We have -5 to 6. Domain is x is such that we're going from -5 to 6. And we're not including -5, but we're including 6. Comma, x is an element of the reals. All of the x's are greater than -5, but less than or equal to 6. For the range, we're going from here to here, to 4, 6, 7.5. Y is such that we're going from 4 to 7.5. We don't include 4, but we include 7.5, comma, y is an element of the reals. The y's are bigger than 4, but less than or equal to 7.5. We have the domain going from -5 to 6. We're not including -5, but we're including 6. And the range, we're going from 4 to 7.5. Not including, but including. Good job. We've had a look at set notation versus interval notation. Make sure you know the symbols for each. When you include the point, remember you need to have the equals underneath the greater than or less than signs. And when there's an open circle, we don't have the equals. We can write domain and range for continuous graphs and also discrete graphs when we have points involved. But remember, set notation can be written with all of them. Interval notation is used for continuous graphs.